Hello and welcome to another Teacher Tobin tutorial. Today I would like to introduce 3DC, which is a great 3D modeling program for the iPad. You might want to use this if you're a teacher that's using the SAMR model and you want to modify or redefine some of your tasks using technology, or if you're a STEAM curriculum and you want to use something that's accessible, if you have iPads at school, for example. Now, 3DC is a great way of dipping students' toes into 3D modeling and developing spatial awareness and problem-solving skills. And it works pretty quickly. It's pretty reliable, a few bugs here and there. It's essentially free. There's a little subscription feature for pro features like dimensions and adding photos for textures, but you can get going with this pretty much straight away. So today this project is going to use Crossy Road, which is a computer game I think owned by Disney, and the characteristic of sort of blocky graphics, sort of 8-bit style, but you can replicate something like this in 3DC without too much trouble, and it's a great way of students to build their own sort of environment, their own world, and get some real results out of it. I think within a 90-minute class period you could probably teach most of the basics of the program, and then for homework I would get them to make a car, which is I'm going to show you in a minute, and then maybe the next lesson you get them to start building an environment. Now there are lots of techniques here, and there's going to be a lot of logic and using Boolean operations, which in 3D means cutting things out from each other. So I'm going to give you a brief introduction of 3DC, how to use primitive shapes, the basic shapes, cubes, toruses, spheres, etc., pyramids, then how to remove something from another shape, how to change the color, and also go through this project piece by piece, and I might speed up some of these videos and narrate over them, and you should get a sense of a real-time problem solving, because I've never done this before. I haven't done this project before, so I'm going to be doing it in real time from scratch. And that means I might make mistakes, and it might echo the problem-solving process, which I think it's more accurate to do from the beginning, because you'll have to maybe go back, stop, start, change something around. But I'll do that live, so you'll be able to see how I can solve problems, and this might echo some of the problems your students might have when doing this project. Anyway, without any further ado, let's get started. You can log in with Facebook, Google, or if you're in a territory like China where you need a VPN for those servers, you can actually create a no account. It's quite useful, so you can use the program straight away with no online service. So that's pretty handy. So students can get straight in. So on the bottom right, you can see you've got move, scale, and rotate. The rotate's the only one that's not the most intuitive to use, but you'll get used to it. You can add most of the primitive shapes you'd expect in most 3D programs: the torus, triprisms, cones, cylinders, cubes, pyramids. You can actually create your own shape there, so when it's a closed shape you can see green and you can actually add it as a 3D shape. Text tool, which is good for name tag projects. You can make your own name tag and then present it to a 3D printer. You can export DAE files, STL or OBJ. They behave nicely with a 3D printer as well. The addition of a plane primitive is really useful. It's going to save a lot of time. Now the subscription model allows you to put in pro dimensions and also add textures or photo textures to these shapes, which is pretty good. It's not the cheapest of subscriptions, but to be honest, the free version is good enough for most school use. So you've got the export options in there. You've got some dimensions and snap to grid. You've got to keep attention to where that snap to grid feature is, because you might need to toggle that on and off more often than not. Starting off with a cube, if you wanted to subtract a sphere from that cube, add a sphere. Let's say you want to scale that sphere. Well, go through each axis and scale it down. Look at the top, and that millimeter measurement is what you want to match each number to. So as long as you match the X, Y, and Z, you're going to get the scaled object. So you've got that selected, only the sphere is selected, and you just press subtract. Whatever's surrounding it is going to remove itself from whatever it's surrounding. So you can see there, half of that sphere has been removed from the cube. So it's fairly straightforward. and it's pretty smooth. I mean, we got more complex shapes, you can run into a few bugs, but for some simple operations, that's pretty solid. I suggest you give your students a project to make a car, because they don't have to do any Boolean operations. They simply have to scale and move cubes, and you start with a cube primitive, and they snap to grid. They can keep the snap to grid on for most of this. Occasionally they might have to turn it off for fine tuning of positioning, like the window mirrors. But other than that, almost everything can be done with the snap to grid on. And then they create their own little car. They need to save that as a separate model, and because you'll need to use that for importing into your scene later on. Now, of course, they could choose different vehicles. They could they could have some creative freedom with that. And for more advanced students, they could make things like tanks or tractors or lorries. But they could certainly start with some basic submission requirements like 4 wheels, a chassis, windows. Now, making a tree. What I'm doing here is I've turned the snap to grid off, and then I'm just turning it on again because I want to clone those 2 planes and snap it to the same position, and I'm just going to move it to the other side. Now I'm going to turn snap to grid off again so I can fine tune the position of them so they're just protruding the tree, only just, so they can be visible. Save that model, and those are just cubes that have just been scaled. So the cube primitive. So you can import that tree later on into your scene. So start with a grey tarmac plane, and then make another plane, and then scale it in one axis to make a long, thin plane. And those will be the road markings. And I'm just slightly adjusting the position there so I can see the road markings above the plane. And then I'm going to go to Tools, and then clone that plane. So I had both of those things selected instead of just one, so you just have to be careful about that. And use the move tool, and it's all snap to grid, so it's just going straight to that grid line. Super useful. Have those parallel to each other, and I'm going to move that one and then move that over. Now that's going to be the boundary, so that's with the bank where if you cross the road you're safe. So that's going to be green in this case. I'll make that little green bank. And what you want to be doing is try to think about problem solving here. Instead of just making everything individually, make part of something and then array it, you sort of clone it. So that's what you want to get your students to start doing in terms of problem solving. So you'll see here that I'll select 3 objects and then clone them, and then I'm going to move them. I've got a snap to grid on, and I just move all of it. So I'm just doing it by eye. It's not like super accurate here. Let me do that another time. And there I've got an array. So it's much quicker to create a sort of tessellating pattern or array of things than doing everything individually. Less errors as well. So I was just extending, scaling my tarmac underneath to suit. There we go. And I might need to just slightly position with a snap to grid off the underground, the tarmac, so it's just snugly underneath. So I've just selected all of those 6 lane markings and moved them out of the way, and I've cloned them. And what I'm going to do here is just by eye, just add an array of those markings, just completely parallel to each other, equidistant, and you'll see why in a moment. So once I've got a few of those, I'm just doing it by eye, so it's not perfect. I mean, that third one from the right, I need to move over slightly. There you go. And then if I select all of those, what I can do then is rotate them 90 degrees and subtract them from the road markings. And this is the sort of problem solving you want to get your kids to be doing, because I can guarantee you that some of them will be sat there making every single road marking as an individual little cube and scale it, instead of doing something like this, which is actually more problem solving. So here they're all the same size. I'm scaling it in that Z-axis, so I want them to be protruding. So all I did there is just press subtract, and then it's removed itself. I grouped them as well. There's a group feature. You can group all of those objects together, and they've just been removed from all of them at the same time, so it's much quicker. And I added those as a group as well, so I can move them as one thing, one entity. So here I'm just making it just protruding from the floor there, just protruding out from the floor. I want the bank to be slightly raised. Snap to grid off to do that, just to make it a little bit protruding. There we go. Yeah, that's better. You don't want it to look too visually 3D. Okay, so I'm going to import my car model here. You can see I'll need to rotate it 90 degrees. Now the problem is, if you've imported that model and you want to change the color of the car, it's going to change the color of the whole thing, which you'll see in a second. So really, if you've got different color cars or different vehicles, save them as separate objects. So if I try to color that, yeah, you see it's just adding one color. So make them as separate models, and then you can import them later. Ungrouping. Okay, so I'll do the same with the tree. I'll load the tree. I'll scale that tree up a little bit. I'm going to move it over. I'll probably need to move it up, and there you go. And pop them up just so they're just slightly protruding. And there we go. There we have our scene. So fairly quickly you can start to actually build up a pretty complex 3D model environment, and the students love this because they can have almost complete control of the environment. You just give them some basic parameters of the aesthetics you're looking for, and of course they can go to town with their themes. I mean, you could have a whole lesson of them going through the basic tools of 3DC and then developing a plan for their theme. So, if it's Pac-Man, for example, then the shapes could relate to Pac-Man and the colours relate to Pac-Man. Or it might be a sort of ice theme, something like that. So you might want to create some geometric snowflakes or some snow vehicles. And maybe a Western theme or fire or something like that, or even Star Wars, something like that. Use the other Disney properties. So I think Crossy Road is owned by Disney. Anyway, this or create animals or avatars or characters. That's another step as well they could work on. So you could really expand this. I mean, it could almost be a mini unit to work on, depending on how advanced the students are. But they'll get some pretty quick results. And anyway, let me know in the comments how this goes. If you get any good results, do let me know, and stay tuned for future content.